नेब एग्जाम को टेंशन? चिंता ना करा. Stressed about your computer science exam? Don't me. We are going to crack 2 of the most important 5-mark questions, and we're going to do it step by step, together.
Okay, let's dive right in. Our first mission to absolutely nail this exact question from a past paper. Describe OOPS with its features. This one is a classic, pretty much a guaranteed 5-marker, so let's lock this down.
And once we've got that in the bag, we're moving on to mission number 2. Another 5-mark question you'll almost certainly see. It's all about checking if a project is even a good idea before you start building. It's a really, really crucial concept. All right, let's get into our first topic, unlocking OOP. I know, the name object-oriented programming sounds kind of scary, but don't let it fool you. It's actually just a super smart and organized way to think about and write your code. And look, just to show you we're on the right track, this is coming directly from Chapter 5 of your textbook. This isn't random stuff, it's pulled straight from your syllabus, so you know this is exactly what you need to focus on for the exam. So what's the big deal with OOP anyway? Well, think about it like this. On the left, you've got the old way of doing things, procedural programming. It's basically one long, massive to-do list for the computer. It works, sure, but it can get messy really fast. And then you've got the OOP approach on the right, building with smart, reusable blocks of code, kind of like digital Legos. So here's the bottom line. Object-oriented programming, or OOP, is all about this idea of objects. Just think of these objects as super useful little containers. They hold both the data, like a person's name or age, and the code that can do stuff with that data. It's all about modeling the real world right inside your program, which makes everything way more organized and a whole lot more powerful. Now, if you want to get those full 5 marks, you can't just define OOP, you have to explain its main features, what we call the 4 pillars of OOP. So let's break them down. And here they are, the big 4: class, object, inheritance, and polymorphism. You've got to remember these 4 names. They are the absolute heart of OOP, and we're going to break down each one nice and simple. All right, first up, class. So what exactly is it? Think of it like this. A class is just a blueprint. It's the template. Let's use a video game analogy. The game designers create a mage blueprint that defines all the basic stuff, like health, mana, and basic spells. That blueprint? That's the class. So, if the class is the blueprint, then an object is the actual thing you create from it. It's the real deal. When you take that mage blueprint and create your specific character, give it a cool name, and set its unique stats, that character is an object. It's a real instance of that class. Okay, this is where it gets really, really cool. Inheritance. This is just a fancy word for how a new class can get, or inherit, all the powers from a class that already exists. Sticking with our game, imagine you want an ice mage. Instead of building it from scratch, you can have it inherit everything from the basic mage class, and then just add some new ice powers on top. It saves you a ton of work. And our final pillar is polymorphism. It sounds super complicated, I know, but the idea is actually simple. It literally means many forms. Think about the attack button in that same game. When you press attack with your warrior, what happens? He swings a sword. But when you press that exact same button with your mage, what does she do? She casts a fireball. See that? One action, many forms. That, right there, is polymorphism. Awesome. Mission 1 complete. We've cracked OOP. But, you know, writing great code is only half the battle. You need a solid plan, a blueprint for the whole project. And that's where the software development lifecycle, or SDLC, comes in. And again, just to be clear, we're pulling this straight from your textbook. Chapter 6, Software Process Model. The exam question we're about to tackle is a core idea from this chapter. So yeah, you're in exactly the right place to nail this question. So what on earth is the SDLC? In simple terms, the software development lifecycle is the master plan. It's the set of steps that professionals follow to take a project all the way from just a simple idea to a full launch and beyond. It's basically the roadmap for building software. Okay, so the question on your exam zooms in on one super important step right at the very beginning of this roadmap. Before you even think about writing a single line of code, you have to test your idea by asking one big question. Is this project even possible? That's where a feasibility study comes in. You can think of it as just a smart way of stopping and asking, hey, is this actually a good idea? It helps you decide by looking at 3 key questions. And to make this super simple, let's pretend we're planning a big college festival. And it does that by looking at 3 key things. which, surprise, surprise, are the 3 types of feasibility analysis you need to know for the exam: economic, technical, and operational. Let's use our College Fest idea to see what each one really means. First up, economic feasibility. This is the money question. Can we actually afford to do this? And will the benefits we get from it be worth more than what it's going to cost? For our College Fest, it's simple. Do we have the budget for the bands, the stage, the security? Bottom line, does the money make sense? Next, technical feasibility. This one is all about the how. Do we have the right technology, the tools, and the skilled people to actually pull this off? For our fest, that means asking, do we have a sound system that won't blow out? Do we have a tech crew that actually knows how to work the lights and soundboard? And finally, we have operational feasibility. This is all about the real world. Even if we've got the money and the tech, will it actually work in practice? For our festival, this is all about logistics. Can we manage the crowd? Do we have enough volunteers? Can we get the right permissions? Basically, can we actually pull this thing off on the day without it turning into total chaos? Okay, take a deep breath. We have covered a lot, but now for the best part. We're going to put it all together into one final cheat sheet, a super fast recap of everything you need to remember. Okay, get ready to screenshot this, because this slide is basically your 10 marks all in one place. Ready? OOP is building code with reusable objects. Class is the blueprint. Object is the real thing. Inheritance is inheriting features. Polymorphism means one action, many forms. And a feasibility study checks if a project is economic, technical, and operational. This is it. This is your key. And just like that, we're done. We've broken down 2 of the heaviest hitting questions for your computer science exam. But just for a second, let's think beyond the exam. You now know about the tools to build things with OOP and the blueprint to plan things with the SDLC. So the real question is, what problem are you going to solve first? Good luck with your exams. You are absolutely going to crush it.